Good morning, sir and madam. Before we begin, let me introduce myself briefly. I'm Adi Widianto and I'm the representative of our research team, which leads by Mr. Tuswan. Today, I'm going to talk about conceptual design and performance evaluation of COVID vessel for public health supplies in Indonesia's remote island. There is a table of content of this session. It's introduction, theoretical basis, result and discussion, and conclusion. In this chapter, I will tell you about our background of our research. The first reason is coronavirus disease 2019, and the second reason is minimum health supplies in Indonesia's remote island. The number of healthcare supplies in Indonesia has not kept pace with the number of remote islands. These desert islands are located distant from urban areas. The great distance, lack of public transit, lack of information and communication make the desert island a several health concern. Because of that, hospitalship is the effective solution. Hospitalships can speed up the fulfillment of health facilities, are the fastest solution than building hospital with huge cost and time. Hospital ships can move place to place by the sea and great small island quickly, which are not accessible by land transportation modes. There is a several research progress about hospital ships in Indonesia. Then we go to theoretical basis. The first chapter is surf resistant and powering. There are several methods to find the ship's resistance. One of them is Holtrop method. The general formulation of resistance using the Holtrop method is shown in the formula below. The RT is total resistance, and the RF is frictional resistance. 1 plus K1 is the form factor describing the viscous resistance. Correlation with RF, and RAPP is appendage resistance, RB is wave resistant, RB is bulbous resistant, RTR is transom hull form resistant, and the RA is ship model correlation resistant. The other method is resistance. Resistance is the used for estimating the resistance of single screw cargo ship. Table 1 is show the Holtrop and SER16 algorithm. There are several requirements to use of the ship is can analyze with this method. Then we go to seakeeping of ship motion subchapter. The seakeeping is a movement that influenced by external force caused by seawater condition. There's a two main part of seakeeping. The first is heading angle and the second is RAO, or also known as response amplitude operator. Heading angle is an angle between the direction of the wave movement and the direction of the ship's speed, which must consider when analyzing the ship's movement. RAO is a transfer function that converts the wave force into a dynamic reaction to the structure and the frequency range. Figure 2 shows the 6-degree freedom of the ship motion and heading angle of the ship's against waves. Then we go to result and discussion chapter. In ship data and design chapter, the figure 3 show the line plan of the KM Lotus, which show the three different perspectives such as body plan, shear plan, and half grid plan. And there is the ship data of the KM Lotus, displacement of 1,261 tons, LPP is 58 meter. Height is 4.02 meter, draft is 2.71 meter, and the surface speed is 12.22 knots. There is a 3D conceptual design of KM Lotus. The KM Lotus ship design is used as medical facility to deal with COVID-19 pandemic in the Indonesia archipelago, especially for remote area. The KM Lotus is designed as medical hospital type B. KM Lotus is equipped with two small boats which can operate automatically, and it can help the rapid handling of the coronavirus. Then the subchapter on concept of medical facility, there is a recommendation for medical vehicle, and the KM Lotus adopt a Class B hospital standard. A Class B general hospital standard must have facility and medical service capability of at least 4 basic specialists, 4 medical super specialists, 8 other specialists, and 2 basic subspecialists. And we go to result and discussion of the shapes. Then the concept of medical facility is the vehicle is equipped with an ICU for handling COVID-19 patient. Then the patient who are still suspect of having COVID-19 will be quarantined in the inpatient room. Then in the room zoning is division or grouping of space based on similar characteristic, function, and activities for certain purpose. Figure 5 shows the room zonation on the general arrangement of the shapes. Then we go to result of resistance test and powering subchapter. This analysis using 2 approaches, numerical and analytical approach. Analytical approach is used to validate the numerical approach. The validation test between Holtrop and Holtrop method and series 16 is conducted at speed of 10 knots. Then the analytical resistance is about 66.36 kilonewton and numerical is 66.6 kilonewton in Holtrop method approach. The error results between the two methods is 6.36%. There is an 8% gap between numerical Holtrop and series 16 numerical series 16 in the highest float number. As for the power requirement result, at speed of 12.22 knots, the ship requires 419 HP when use the Holtrop method and 383 horsepower when use series 16. Then we go to result of ship motion. The subchapter will investigate further seakeeping behavior by comparing the RAO of heaving, rolling, pitching, and the hull using the 3 different encounter waves. This analysis was carried on simulating ship speed in 12.2 knots, and the average head wave value is 1.9 meter in Maluku Sea based on BMKG Sea Forest System. Figure 7 show the heave motion. Peak of RAO found in the blue line as known as beam C, encounter frequency is 1.42 radian per second and the RAO value of 1.1 degree per meter. Then is the roll motion, and the beam C and bow curtain has an RAO value of 6.5 and 4.6 respectively, and in contrast the arrival of head C at 0, because of the arrival waves from the front does not affect the ship's left and right rolling motion. And the last is the pitch motion. The peak of RAO is encounter wave from head C at encounter frequency of 0.87 radian per second and the RAO is 1.07. And in contrast, pitch motion had the lowest response. It means that the heading from 90 degrees has little effect on the pitch motion. Then we go to conclusion chapter. COVID Faisal KM Lotus designed as Type B hospital, which have 1,000 and 2,069 tons and length of 16 meters. The velocity speed is 12.22 knots and equipped with dynamic positioning system. And DWT component is compressed with consumable item, and LWT component are derived by hull wedge, machinery, outfitting, and medical equipment. And the third conclusion is good agreement can be achieved with a small error in validating the resistance test between analytical and numerical methods. The resistance test using the Holtrop method has a value of 66.6 kilonewton and the power of 383 horsepower at ship speed of 12.22 knots. Then the last conclusion is the seakeeping performance test based on Maluku Sea data show the highest HEP RO can be found in the head sea. Moreover, heading from 19 degree has the highest roll motion and the peak of pitch RO can be found at head sea condition. I hope my session was valuable and will encourage the future research about hospital vessel, especially for Indonesia remote island. Thank you for your attention. Good morning.